In this scene, what we have here is a turbulence container, which is right now not displayed in the viewport, but I'll display it, and I'll show you the simulation that is doing. And you can render this turbulence FD in various ways. You can use the turbulence FD source. You can pick that container, and everything else currently is pretty much disabled except for light that is illuminating it. It's set to a smoke shader, and the voxel spacing is set to 1, and this is pretty much the same spacing, the voxel size that the container was using during the simulation. So I'll open my render settings, make sure that everything is cool here. We're going to the view, and I'll try to render with the current settings as it is and see what I'm going to get. What it does at this point is actually taking the voxel grid from the simulation, and I'll go down with the density, and basically creating one particle within each voxel of the simulation. This one started getting more bright, so I can potentially let more light go into it, or I can just go with the density so low that it gets very smoky. Remember that we're actually using currently the smoke shader here in the settings of the turbulence FD. So we're actually asking for the color that the turbulence FD itself would calculate for each voxel, and then we're creating a particle and giving it that same color. And we are rendering currently as particles, and you can see the individual points. Potentially, if you zoom very, very close, you must start seeing a grid there, but yeah, probably not really. What you can also do is you can switch to voxel mode. It is set to 1 centimeter, and you can render each particle as it's coming within a voxel, and that will produce a very similar result, but you have the ability to actually make it even smoother. Remember that this is using world space units, so even if you're rendering at a huge resolution, you don't draw a single point. You can draw exactly a cube of 1 centimeter in size, and it will always look relatively smooth and usable. But let's go back to particle mode, and I'm going to switch now the shader through fire, and I'll render with the fire shader exactly the same particle. So it's going to read the voxels, create new particle in each voxel, and give it the color that the fire shader said it should have, and that's what we start getting here. I can go down 5 times more with the final pass density, and it will get more transparent and less intense. But in general, we are currently converting voxels to points, very similar to the way we're converting a mesh to first a voxel grid, and then in each voxel we create a particle, or the repopulation where we take existing particles, put them on a grid, and then create new particles. So this is a direct way to get the data out of the turbulence and render it directly with the shader that turbulence provides. There is another way, though. I can disable this, and we have an X particle system in the scene. Here is the emitter. I'll go back to the beginning, and I also have an X particle source. And with this simulation, you can advect your particles to actually follow the simulation. So now that I'm advancing the time, the particles, which are shaded by X particles between blue and white, depending on the velocity, are being emitted and driven by turbulence FD. There are tutorials online to show you how to do it, but basically the only thing that you have to remember is that you will have to set the velocity to 100% or higher, or non-zero value because it defaults to 0, in order to apply velocities to particles in the scene. Then if you create TP or XP or whatever, anything that can be driven there will be advected as you need it. In order not to waste time with this, I have already pre-cached my emitter through a PLT loader. I'll load just one partition here, enable it, and I'll disable the display of the actual turbulence because we don't really want that. There were actually millions of particles saved, and right now I'm showing only a small fraction of them, only 2%. If I'm showing it by end particle by ID, it's basically skipping always the same particles, and because particles are dying and you're being born, it's kind of moving a little bit and appearing more. if I increase the count, the percentage, it will start appearing a little bit more dense here. But in general, I created multiple variations of this. So in my particle files here, it actually says I have 10 partitions. I can go and start adding even more to be loaded at render time. And if I would render this, it will look different from the actual particles that we're rendering directly from the simulation. I'll go to about -2 and try to render this and see what we'll get. Keep in mind this is on a different frame, but basically the particles that we are emitting were advected by the fluid simulation, and they're also casting shadows accordingly. In this case, you have all the controls of the color that X particles gives you, instead of using the shader of the simulation, the turbulence FD simulation. So this is an alternative way where you're indirectly rendering the turbulence. You're creating your particles, you're moving them around, and you're actually rendering those particles, which you can affect with different additional forces, fields, multiple fields. In general, you have a lot more ability to control the motion and use the simulation only as an additional modifier to your particles in order to get the look that you want. So both approaches are possible with Cricketer. You can either directly render the turbulence or indirectly using the advected particles like X particles or TP.